The Taj Mahal is universally recognized for its flawless, ethereal aesthetic. It is viewed as a weightless symbol of romance and the pinnacle of Indo-Islamic architectural beauty. The physical reality of the structure is quite different. It is an incredibly heavy, dense masonry complex built directly on top of a highly unstable, saturated environment. Commissioned in 1631 by Mughal Emperor Shah Jahan, executing this design required the deployment of more than 20,000 workers and artisans over 2 decades. The pristine white marble is merely a veneer. Beneath that surface lies a massive, heavy structural core, constructed almost entirely of red brick and mortar. To understand how this structure actually stands, we have to reverse engineer the site, starting from its hidden subterranean foundations and working our way up to the optical illusions on its surface. The monument's timeless beauty is entirely dependent on how 17th century engineers solved a series of severe geomechanical and logistical nightmares. The primary geomechanical threat was the location itself. Engineers had to secure a massive point load onto the saturated, shifting banks of the Yamuna River. Site preparation began at the dirt level. Laborers excavated roughly 1.2 hectares of topsoil, filling the area with specialized dirt to reduce immediate water seepage. To prevent the monument from sinking, the architects implemented a deep pile foundation system. They dug a series of deep cylindrical wells straight down through the mud to reach a stable substrate. These foundation piles were packed with a highly compact matrix of lime and stone, creating unyielding vertical footings deep underground. Directly on top of these piles, workers constructed a thick horizontal platform made of brick and mortar. This leveling platform spans 300 meters in length and elevates the entire construction footprint 50 meters above the river level. If engineers had placed the tomb directly on the riverbank, the immense weight of the masonry would have sheared the soil, dragging the structure into the Yamuna. Above ground, the true structural skeleton of the Taj Mahal is built from brick and mortar. This presented an immediate logistical problem. Standard 17th century wooden scaffolds could not physically bear the immense weight of the masonry required to reach the upper levels of the dome. The engineers deployed a radical solution. They built a colossal secondary structure, a scaffold made entirely out of solid brick that mirrored the tomb itself. This immense support framework introduced a new challenge, transporting thousands of heavy stone blocks vertically to the height of the dome. To bridge the vertical gap, workers constructed a 15-kilometer-long earthen ramp extending outward from the site. An expansive animal-powered logistics network moved the materials. Teams of oxen and elephants hauled specially constructed wagons heavily loaded with stone up this incline. At the top of the ramp, elaborate post and beam pulley systems hoisted the heavy blocks off the wagons and lowered them into their precise positions. The illusion of effortless beauty we see today is the direct result of extreme logistics and the manual movement of millions of tons of earth. With the logistics handled, the architectural geometry took over. The central mausoleum sits on a square plinth measuring 95.5 meters on each side. The base structure is a multi-chambered cube, but its corners are chamfered, cutting away angles to create an 8-sided shape known as the hashed behesht plan. Utilizing perfect bilateral symmetry, the geometry evenly distributes the immense downward force to the 8 load-bearing walls. The primary vertical load the structure must support is the massive 23-meter-high onion dome crowning the tomb. Notice the dome does not sit flat on the roof. It rests entirely on a hollow, 12-meter-high cylindrical drum, which artificially increases its vertical profile without adding solid, unmanageable mass. Surrounding the main dome are 4 smaller domes, called chhatris. These replicate the onion shape, adding crucial downward load balance at the corners, while bringing natural light into the interior. The site's strict symmetry operates as a highly efficient mathematical model for bearing weight safely over time. Once the structural skeleton was secure, laborers applied the final surface finishes, veneering the massive brick core entirely in flawless white Makrana marble. For the surrounding buildings in the complex, they used red sandstone from Fatehpur Sikri. This created a deliberate visual and material hierarchy, reserving the pure white marble strictly for the mausoleum. The surfaces were then intricately decorated using the pietra dura technique, inlaying 28 different types of precious and semi-precious stones directly into the marble base. The engineers also applied specific optical corrections to force a perspective of perfection, beginning with the Arabic calligraphy framing the massive archways. Viewed from below, perspective skew normally causes text to appear distorted or shrunken at the top. To counteract this, engineers deliberately scaled the letters to gradually increase in size as they rise along the archway, making them appear perfectly uniform from the ground. A second optical and structural correction involves the four 40-meter-tall minarets flanking the tomb. These minarets are not perfectly vertical. They were carefully engineered with an intentional outward tilt. This serves a strict geomechanical purpose. In the event of an earthquake or structural failure, the towers will collapse outward and away from the main structure, ensuring the central tomb remains protected. The visual perfection of the Taj Mahal is not a natural occurrence. It is actively forced through deliberate optical and physical distortions. The entire project was completed in 1653, requiring over 20 years of uninterrupted labor. It cost an estimated 32 million rupees, equivalent to over $820 million today. The complete 17-hectare site functions as a cohesive, interconnected machine, extending outward into the formal Charbagh Gardens. These grounds rely on a hidden hydraulic infrastructure. Animal-powered pulleys were utilized to draw water directly from the Yamuna River, lifting it into a massive raised holding tank. Gravity then distributed this water through an underground network of earthenware pipes, generating enough pressure to autonomously power the fountains inside the reflecting pools. From the subterranean piles and 15-kilometer ramps to the optically scaled calligraphy and seismically tilted minarets, every single measurement was calculated. The Taj Mahal will always be defined by its history as a monument to royal grief, but it continues to stand today entirely due to its reality as an uncompromising masterpiece of civil engineering.